Myself, Mrs. Charushila Vijayarani. I will be discussing one of the practicals for the subject digital signal processing, which is for third year ENTC students for the semester 1. So aim of the experiment is design and implementation of two-stage sampling rate converter. The system which is using single sampling rate for analog to digital converging is referred as single rate system, and the discrete system that process data at more than one sampling rate are known as multi-rate systems. One of the example of multi-rate system is mentioned here. In case of digital audio signal, different sampling rates are required as per the application. If we are trying to broadcast the audio signal, we need 32 kilohertz sampling rate. If it is an application of storing the data on compact disc, then we need sampling rate of 44.1 kilohertz. And if it is for audio tape recording, then we need 48 kilohertz of sampling rate. So here different three sampling rates are required for the same audio signal depending upon the application. So there are many areas where the multi-rate signal processing is used. Some of them are listed here. In high quality data acquisition and storage systems, in audio signal processing, in video signal processing, speech signal processing, in trans multiplexers, or for narrow band filtering. In this sampling rate converter, there are the two types. Depending upon your upsampling, or you are increasing the sampling rate or you are decreasing the sampling rate. Depending upon that, there are the two types of this sampling rate conversion. First one is the interpolation. It is a process of increasing sampling rate. So interpolation is also called as upsampling. So in that interpolation, the resultant signal y of n will be changed as x of n, n by L, where x of n is the original signal. If you are applying an interpolation with factor L, then the resultant signal y of n will have the equation x of n by L. So as per the operations on signal, we can say that this is a time expansion operation. Graphically also interpolation is explained here. Suppose this is the original signal with 30 number of samples are existing in that. Now if we are trying to interpolate it with some factor, then for the same signal we can see the increased number of samples. Here originally the signal is having 30 samples, and after interpolation it is having 120 number of samples. That means the 4 times number of samples are increased. That is, interpolation factor is 4. If the signal is represented in this form, in this curly bracket, the amplitude values of the signal are mentioned. Since arrow is not indicated in the presentation, first value will be considered as a sample at origin, which is having amplitude equal to 1. Now, if you are upsampling the signal, original signal x of n, by the factor 2, then its equation becomes x of n by 2. And the samples will be like this. Here we can observe that in between the zeros are inserted to increase the number of samples. If the upsampling factor is 3, then we can say that the equation of resultant signal y of n becomes x of n by 3. And the amplitude values of the signal are like this. Here 2 zeros are inserted after every sample of the original signal. That means the number of resultant samples are 3 times of the original, because your upsampling factor is 3. The same signal x of n is shown here graphically. The amplitude values are 1, 2, 3, 1, 2, 3, likewise. Now, if our signal y1n, resultant signal y1n after interpolation with the interpolation factor equal to 2, we can see here that after every sample, 1 0 is inserted. After every sample, 1 0 amplitude is inserted to increase the count of number of samples. In the next stage, which is a output of interpolator, we can see that at the positions where the zeros are inserted, the samples are added. Those are relevant to the nearby samples, adjacent samples. So if you are comparing the number of samples in the original signal x of n and the interpolated signal y2n with the interpolation factor 2, we can see that the number of samples or number of elements are doubled in number. Now, another way of sampling rate conversion is decimation. So it is a process, decimation is a process of decreasing the sampling rate. Decimation is also called as downsampling. So if the original signal x of n is downsampled or decimated by the factor m, then resultant signal y of n will be having the equation x of m into n. In interpolation, we have seen that n is divided by the interpolation factor, and here in decimation, the time parameter n is multiplied with the decimation parameter m. So operation wise, we can say that it is a compression operation. So downsampling by an integer factor m means what? We have to retain one sample and we have to discard remaining m minus 1 samples from a bunch of m samples. If we are considering a bunch of m samples, we have to retain one and the remaining m minus 1 samples we have to discard. If compared with interpolation, in interpolation we have added the samples, and in decimation we are going on discarding the samples. So here the same signal x of n is taken as an example, which is having amplitude values 1, 2, 3, 1, 2, 3, 1, 2, 3, continued. Now, if I am decimating the signal with the factor equal to 2, then you can observe here the resultant signal after decimation from a bunch of 2 samples. I am retaining one and the remaining are discarded. Then I will take the next bunch of 2 samples. First one is retained, remaining are discarded. Same thing will be continued. Next example, if the decimation factor is 3, then from the original signal we have to consider a bunch of 3 samples, retain the first, and the remaining m minus 1 we have to discard. That means 3 minus 1 equal to 2 samples we have to discard. Then consider a bunch of 3 samples, retain the first sample and discard the remaining, and that will be continued. So these are the resultants of decimation with decimation factor equal to 2 and decimation factor equal to 3. Same signal is shown graphically here. Original signal x of n with the amplitude values 1, 2, 3, 1, 2, 3 repeated. Then decimation factor is 2. That's why the resultant signal y of n is equal to x of 2n. X of m into n, m value is equal to 2. That is decimation factor is equal to 2. So we can see here from a bunch of 2 samples, we have to retain one and another one we have to discard. Next, we will take the bunch of 2 samples, retain the first one, discard the remaining one, and that will be continued. Another example, the decimation with the factor 3. So in that, take a bunch of 3 samples, retain the first one, and remaining 3 minus 1, that is m minus 1 equal to 2 samples we have to discard, and that will be continued for all the locations. So here, if you are comparing the number of samples in original signal and the decimated signal, we can see that the number of samples are reduced in number, and the reduction depends upon the decimation factor. Here, if this is the original signal with 120 number of samples, then after decimation, we can see here the shape is retained, but the number of samples are reduced, right? If the sampling rate is satisfying the Nyquist rate, then only um, this reconstruction of the original signal is possible with the help of this reduced number of samples. Here originally the number of samples are 120, and after decimation we are having 30 number of samples. That means the decimation factor is 4. Now same thing we will discuss with the help of MATLAB software. So for that purpose, to use the MATLAB online, you must have the registration for this. In your Google window, Google search window, type MATLAB online, then you will get this window. On this window, there is one option, start using MATLAB online. Click on that. Since we are using it online, it will take some time depending upon the internet speed. Okay. Now the MATLAB software is ready to accept the code. So in the MATLAB programming, here always first statement will be the comment which is mentioning the title of our title of our experiment. So design and implement two-stage sampling rate converter. Clear all, close all, and CLC. These are the common instructions which we are using for all the experiments. Clear all instruction will clear all the parameter values. Close all will close all the windows opened, figure windows opened. CLC will clear the command prompt. Means because of previous execution, if there is any data available on the command prompt, that will be cleared with the help of the CLC instruction. Next, through the keyboard, from user we will accept some of the input parameters. So for that purpose, input is the inbuilt function used, which is used to accept inputs from user through keyboard. And whatever is the accepted value, that will be stored in these variables. So first statement is f equal to input, enter the frequency of signal. So first of all, one original signal we are going to generate. To generate that signal, what the frequency is expected, that input is asked from user. Then second parameter, interpolation and decimation factor is also accepted through the keyboard from user. Then enter length of signal. What should be the number of samples available in your original signal, that is accepted through keyboard, and that is saved in parameter L. In the next line, t is equal to 0 to L minus 1 with the step size 1 is the instruction given. So this particular instruction will assign the values to variable t starting from 0 to L minus 1. L is a number of elements or number of samples we are requesting in the original signal. If it is 50, suppose, then p values will start from 0 and it will end at 50 minus 1, that is 49, with the step size equal to 1. The middle figure is mentioning the step size, means the next value will be generated with the difference of 1. That means the t values will be starting from 0, next value will be 1, then 2, then 3. This way it will continue up to 49. So this way total 50 number of values are generated for the variable t. Then sine inbuilt function is used here to generate a sine signal. And that signal is saved in the variable x. X is equal to sine 2 pi ft. Whatever is the frequency accepted through user, that frequency will be used to generate the sine wave. Then for decimation purpose, the decimate is the inbuilt function available in MATLAB, and for interpolation purpose, interp is the function available in the MATLAB. So in the syntax for decimation as well as for interpolation, two parameters we have to give as an input. First one is the signal on which we are going to apply the decimation, as well as here interpolation. For interpolation also, first parameter is a signal on which we are going to apply the interpolation. And the second parameter is specifying the respective factor. That is also accepted through keyboard from user. So here through one line function, through one line command, since the inbuilt functions are available, we can decimate the signal as well as we can interpolate the signal. Now the next task is to observe the resultant signals. For that purpose, we have to plot these three signals. Three signals means first one is the original signal, second is decimated signal, and the third is interpolated signal. So since I can observe all the three signals parallelly, I need to divide the figure window in three sections. For that purpose, subplot is the instruction available. Since I want the three subsections, I will give the parameters for subplot instruction as 3, 1, means I'm going to divide the figure window in 3 rows and 1 column. This way I will be getting 3 subsections. Out of these 3 subsections, first section is used for the purpose of plotting of the signal x. X is nothing but the original signal. X is nothing but the original sine function, which is generated as per the inputted frequency. And the title to that waveform is given as original signal. Then out of these 3 windows, I am going to use the second section to plot the function d. What is in d parameter available? D is nothing but the decimated signal. So decimated signal is plotted in the second subsection of the figure window, and accordingly title is given as decimated signal. In the third subsection, the function I is plotted. I is nothing but the interpolated version of the original signal x, and accordingly the title is given as interpolated signal. So if you want to see the details about newly used functions, for example, if you want to know about input function, you have to type help input at command prompt and enter. So all the details related to that function will be available here. What is the syntax, for what purpose we have used this function, all the details we will get. Similarly, help decimate as well as help interp can also be observed on the command prompt. Now we will save the code and then we will execute it to observe the output. Enter the frequency of signal. If it is 50, second parameter asked is enter interpolator as well as decimator factor. Suppose 2. Enter the length of signal. If I want the 50 samples in original signal, I have entered 50. Now this section is the figure window. Here we will get the resultant figures corresponding to the code entered in the editor window. So here we can see, because of the subplot instruction, the figure window is divided in 3 parts. Since the subsections are one below other, 3 rows are there and single column is there. That's why the syntax for subplot is like this: 3, 1. First parameter is specifying the number of rows required, and the second parameter is specifying the number of columns required. So out of these three subsections, first section is used to plot the original signal. So this is the original signal which is containing 50 number of samples. Then decimation factor is entered as 2. That means after decimation, I should get half of the samples. So here we can see the samples in the decimated signal are 25. As well as in interpolated signal, the number of samples are doubled if compared with the original signal. That is 50 number of samples are converted in 100 number of samples. You can see the shape wise, the shape of the original signal and the interpolated signal is matching with the increased number of samples. So that is the concept of decimation and interpolation, which is nothing but the sampling rate conversion.